All right, guys, we are going to do the foldable that looks like this. So it's the Converse theorems. So get it out. And the first thing that I want you to do with it still flat before you start folding it is cut out this little piece right here where it says cut this flap off. All right, so after you've cut the flap, it looks like this. Now, as you can see, this right here is dotted. We're eventually going to fold that over, okay, to where it looks like this. But each of these are going to be flaps too. So before we even fold it over, I'm going to go and I'm going to cut along these lines, but stop at the dotted lines. Okay, so go ahead and cut along the solid lines here, here, and here, but stop and don't cross over that dotted line. All right, so now it should look like this where you have all these flaps. So go ahead and fold the flaps over on this dotted line here. And your foldable should look like this. Hopefully you took time and folded it a little better than I did. But at the top it says how to prove two lines are parallel, and then there's flap, 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 and flap. Okay, now we're going to go through and fill those inner parts of the flap out. All right, so the top flap is the alternate interior angles Converse. So just as a review, alternate interior angles, alternate means they're on the opposite sides of the transversal, and an interior means they're between the two parallel lines. So I'm just going to highlight. So this angle in yellow and this angle in yellow would be alternate interior angles. Okay, and then this angle and this angle would be alternate interior angles. So the same colored angles would be considered a pair of alternate interior angles. Okay, now we only use these Converse statements when we are proving lines are parallel. Okay, Converse. So when proving lines are parallel. Okay. So the statement here, it says if two lines are cut by transversal so that alternate interior angles are congruent, then the lines are parallel. Okay, so I'm just going to go ahead and label these. This could be 1, 2, 3, and 4. Okay, so if I could say if angle 1 is congruent to angle 4, then I can conclude that J is parallel to K. Or I could have also said if angle 2 is congruent to angle 3, because those are also alternate interior angles, then J would also be parallel to K. All right, now the second flap down is the alternate interior angles Converse, and once again, this is the converse of the alternate exterior angles. Now remember, when we're talking about the converse statement, we're flipping the hypothesis and the conclusion. So before we said that if the lines are parallel, then alternate exterior angles are congruent. Now if we say the converse of that, it's if alternate exterior angles are congruent, then the lines are parallel. So that's what this is saying. So just as a review, alternate exterior angles, alternate means they're on opposite sides of the transversal, exterior means they're outside of the two parallel lines. So this angle in blue and this angle in blue would be alternate interior. Okay, and then this angle here and this angle here, both in green, would be alternate exterior. So let's go ahead and just label them 1 through 4. So say 1, 2, 3, 4. Okay, so if I were to fill in this right hand side, it says if two lines are cut by transversal so that the alternate exterior angles, and remember the relationship between those, are congruent, then the lines are parallel. So in other words, if angle 1 is congruent to angle 4, then J is parallel to K. Or I could also say if angle 2 is congruent to angle 3, because those are also a pair of alternate exterior, then J has to be parallel to K. All right, guys, so the third flap down is consecutive interior angles. So we're going to talk about the consecutive interior angles, Converse theorem. So before we do that, let's review again what are consecutive interiors. So consecutive means they're on the same side of the transversal, and interior means they're between, they're on the interior of these two lines. So this angle and this angle would be consecutive interior. And then this angle and this angle would be consecutive interior as well. You have to know what their relationship are before you can apply these. So this theorem tells us that if two lines are cut by a transversal so that alternate, oh, sorry, we're not doing alternate interior, we're doing consecutive interior, my bad. So that consecutive interior angles are, guys, these are not congruent. These are supplementary. So if the consecutive interior angles are supplementary, then the lines are parallel. So remember, supplementary means they add to 180. You should know that by now. So angle 1, angle 2, angle 3, and angle 4. Let's label them. Okay, so I'm going to write here, if we know that, I don't know, let's do 1 and 3. Angle 1 plus angle 3 equals 180. In other words, angle 1 and angle 3 are supplementary. Then the lines are parallel. Okay, or I could say if the other pair of consecutive interior angles, which is 2 and 4, if those are supplementary, so if angle 2 plus angle 4 equals 180, then I could say that J is parallel to K. So either one of those would show that the two lines are parallel. All right, last but not least, the corresponding angles converse. So I'm just going to come down here and highlight each corresponding angle in the same color. I encourage you to pause this right now and you go and decide what angles are corresponding angles. You should know this by now. So go do that real quick and then we'll go over it. All right, guys, so I've went and colored the corresponding angles the same color. I'm going to label them now. So hopefully yours matches up to mine. Okay, so this theorem tells us that if two lines are cut by transversal so that corresponding angles, now hopefully you remember that corresponding angles are congruent, then the lines are parallel. So, for example, if angle 1 and 5, they're both green, so they're corresponding angles. So if angle 1 is congruent to angle 5, then J is parallel to K. Okay, or if, I don't know, 3 is congruent to 7, then J is parallel to K. Or if 2 and 6, angle 2 is congruent to angle 6, that would show the lines are parallel. And last but not least, angle 4 and angle 8, that would also show that the lines are parallel. So that concludes this foldable. Go ahead, paste it into your interactive student notebook. And then there's one more foldable for section 3.3, which is the transitive property of parallel lines. We'll do that in this next video. It'll be super short. And then we'll be done with sections 1 through 3, and we're going to have our first chapter test or half test over sections 1 through 3. So that'll be all the new material we'll cover. But one more video, and then we'll be done with section 3.